Since the discovery of the reason why dinosaurs went extinct, humanity has wondered if the same fate awaits them. In December 2004, that fate found a name, 99942 Apophis. Named after the old Egyptian god of chaos and darkness, the asteroid is 1,210 feet wide and is expected to cruise harmlessly at a distance of 19,000 miles above the Earth's surface. Cutting too close, isn't it? So, is that truly safe? This question has been plaguing astronomers across the world, and if Earth's gravity pulled Apophis closer, an impact can cause destruction that could obliterate an entire city. Our Earth is surrounded by 30,039 asteroids that have the potential to collide with our planet. According to historical data, an asteroid the size of Apophis strikes Earth once every 80,000 years. Does the success of the DART mission prove that we can sleep in peace at night without worrying about the universe chucking life-threatening boulders at us? Welcome to Factnomenal, and let's look at why NASA is worried. Are 30,000 asteroids heading to Earth? In the last decade or so, NASA and other space organizations around the world have discovered alarming numbers of asteroids that qualify to be tagged as near-Earth asteroids, or NEA. The number of space boulders that are in deadly proximity to our Earth currently stands over 30,000, or 3% of the known million units from the asteroid belt, and the number is rising. An asteroid qualifies to be NEA if its trajectory brings it within 1.3 AU, which stands for astronomical units. An astronomical unit is quite a narcissistic method of measuring distance in space, as it equates to the distance between the Sun and the Earth. NEAs conceivably can come within at least 0.3 AU, or 45 million kilometers of our planet's orbit. According to the European Space Agency's asteroid risk list, 1,425 asteroids have a non-zero chance of making an impact on Earth's surface. Although most of these space rocks are harmless and won't hurt a soul, astronomers' biggest concern are medium-sized asteroids that are a few hundred meters in diameter. They are not going to exterminate us all, a la Don't Look Up style. But asteroids the size of Apophis can demolish a city like a nuke. And that is why the fate of our planet was hanging on the success of the DART mission. Hollywood may have taught us that the solution to every space problem is launching a nuke in its face. May that be reigniting the sun or blowing up an asteroid hurtling towards Earth. But unlike the Michael Bay movie Armageddon, NASA opted for a robot to do the job instead of a bunch of severely underqualified plumbers. NASA spent $300 million just to test its new planetary protection technique, and they targeted an innocent asteroid that was never going to hit Earth. The Double Asteroid Redirection Test, or DART probe, launched from Vandenberg Space Force Base in California on an early Wednesday morning, November 24, 2021. DART was riding a SpaceX Falcon 9 rocket, and its destination was Dimorphos, an asteroid that was just minding its business, orbiting its larger companion, Didymos. The aim of this unprovoked attack was science, to find out if DART's self-sacrificing mission to crash against Dimorphos, which occurred on Monday, September 26, 2022, would cause a modification to the orbit of the asteroid through kinetic impact. It took astronomers more than half a month of observation to confirm that the Space Trojan was a success. NASA's DART indeed succeeded in changing the orbit of asteroid Dimorphos, and the Earth now has one possible method of defense against dangerous cosmic bodies on a collision course with our planet. This also marked a huge step for humanity, as it is the first time humanity has purposely changed the motion of a celestial object, and the first full-scale demonstration of asteroid deflection technology for planetary defense. Have you heard that, nature? We are not just messing with you on the planet Earth, but now in space too. But this time it is done for the preservation and not for exploitation. As NASA's administrator Bill Nelson stated, "All of us have a responsibility to protect our home planet. After all, it's the only one we have. This mission shows that NASA is trying to be ready for whatever the universe throws at us." NASA has proven we are serious as a defender of the planet. This is a watershed moment for planetary defense and all of humanity, demonstrating commitment from NASA's exceptional team and partners from around the world. Dimorphos's natural orbit around Didymos used to be nearly 11 hours and 55 minutes before DART's impact. Since September 26th, many astronomers around the world kept their eyes fixed on the asteroid to see what was the outcome of such an ambitious mission, and now the result is in. Dimorphos's new orbit clocks 11 hours and 23 minutes, which means that DART was responsible for shortening Dimorphos's round trip around Didymos by 32 minutes. But keep in mind that this measurement has a margin of uncertainty of approximately plus or minus 2 minutes. The investigation team is still acquiring information using ground-based observatories around the world, but the focus is now shifting to the star of the moment, DART, and the last data it shared with us. Astronomers are now focusing on ejecta, the vast plume of dust and debris blasted from the asteroid's surface that was observed 2 days after the impact. Ejecta, or the dust tail created by the impact, was pushed away by the sun's radiation pressure, similar to the tail of a comet. It could be seen stretching from the center to the right-hand edge of the field of view. The DART team is hoping that these observations would allow researchers to gain knowledge about the nature of the surface of Dimorphos. They will be able to gauge how much material was ejected by the collision, how fast it was ejected, and the distribution of particle sizes in the expanding dust cloud. Did the moonlet asteroid throw off big chunks of rocks, or did it spit mostly fine dust on the impact? This is vital data because not only we are learning about the alterations caused by DART on the asteroid's orbit, but also if the asteroid mostly expelled big chunks of rock. Then doing so to an asteroid approaching Earth would just spread the damage instead of preventing it. It is like being shot by a shotgun shell instead of by a single piercing bullet of a sniper rifle bullet. However, deflection by kinetic impactor is only one of the techniques NASA is planning to deploy as a safeguard against civilization-wiping capable asteroid impacts. But maybe we won't need any of that, because as we are getting closer to the date when Apophis and Earth will be closest, the chances of the impact are reduced to a bare minimum, and astronomers believe perhaps we may not face a cosmic threat for the next century and a half. But it is still a good feeling to know that somebody is keeping a watch out there for us. Thanks, NASA! If you learned something and enjoyed it, please do like, share, and don't forget to subscribe for more videos like this. As always, thanks for watching Factnomenal.